Alright guys, so here we go. Basketball. In the last quarter of a high school basketball game, your team is behind by 34 points. A field goal is 2 points and a foul shot is 1 point. The coach doesn't want the team shooting any 3-point shots. Probably because you're so bad at it and that's why you're losing by 34 points. You're going to let X represent the number of field goals scored and let Y represent the number of foul shots scored. Write and graph an inequality that models the different numbers of field goals and foul shots your team could score to win or tie the game. And we are assuming that the other team scores no more points. So one thing that we're going to have to do is pick out some important information from the problem here. Down by 34 points is definitely something that we should take a look at. Your team is behind by 34 points. What other pieces of information do you think are important here? A field goal is worth 2 points. Definitely important. Foul shot is 1 point. Also important. Yeah, the fact that he doesn't want you shooting any more 3-point field goals tells us that we're not going to have anything that goes up by 3. So just 1 and 2. What else do we need to know from this paragraph? Yes, X represents the number of field goals scored. And Y represents the number of foul shots scored. Looks good to me. Does anybody else think there's anything they can pull from that paragraph? One more piece of information that might be important. Yep, we know that there are no more 3-point shots. What else? Yeah, it tells us that we need to write and graph an inequality. That's going to be, the whole objective of this is to write and graph this inequality. And Carlos, you were saying win or tie. Okay? To win or tie tells us something.
So it could be more than or equal to?
It could be greater than or equal to, because greater than would give us what? Win or tie? A win. And what would equal to give us?
A tie.
Okay, so if we could do win or tie, we need to be greater than or equal to that number of points. And so let's take a look at this. How do we think we should start this whole deal here? Alright, so we have 2x. What does 2x represent? Yeah, points we're scoring with the field goals. Right. So 2 is the points per field goal. Alright? And the x is how many field goals. When we multiply those, it tells us the total number of points that we scored just by the field goals. And so we also know that the y represents the number of foul shots scored. How am I going to work that into this inequality? Why do you say 3y? We're talking about foul shots. How many points are they worth? 1y. And if we know that it's 1y, we can just put y. That's right. So we know that this 2x piece here is telling us the number of points we're scoring with 2-point baskets, the field goals, and y is telling us how many points we are scoring with the foul shots. What do we know about that combination of points? That's absolutely correct. It has to be greater than or equal to 34. Wonderful. Alright, so we have written our linear inequality. So write, done. We now need to graph this. And we've got graphic organizers to help us out with that, right?
Yes.
That's right. The first step is to solve for y. Good call on that. And what does that mean, to solve for y?
To get y by itself.
Absolutely. What we call isolating the variable y, or getting y by itself. So, how am I going to go about getting this y by itself in this problem? We're going to subtract 2x on both sides. So I have 2x minus 2x plus y greater than or equal to 34. Good. Minus 2x. Excellent. Yeah, on the left-hand side here we see that 2x minus 2x is 0, so it cancels out. What left over? Greater than or equal to 34 minus 2x. Excellent. And so we should flip it because we want that slope-intercept form, right?
You bring those, because y greater or equal to negative 2x, and you bring the negative 3.
That is an excellent point. This is y is greater than or equal to. We're bringing this negative 2x out front to model that y equals mx plus b format. And we know that this negative sign has to go with this 2x. So negative 2x. What's the symbol next? Plus 34. How do you know it's plus?
Because it's not a negative.
That's right, because 34 is positive. Excellent. Good stuff, guys. Good.
And then you put 2x, negative 2x, and 1.
Yeah, we see that this negative 2 in front of the x is our slope. What's our variable for slope? M. Yeah, and mx plus b, m is the slope. And if we have negative 2, John, you said that's the same as negative 2 over 1, right? And so, what does that mean as far as moving is concerned?
You go down to 1 third.
Down 2 and 1 to the right. That's right. If it's negative, we go down. If it's positive, we go up. And so, since it's negative 2, we're going to go down 2 and to the right 1.
We start at 34.
We're going to start at 34. What variable do we use for that starting value? B. That's right. B is the y-intercept, and that's that starting or initial value. You see that is 34 here. So now I've got my slope of my y-intercept.
Right on the 35.
Yeah, if we're looking at this, the space between this 30 and this 35 is 5. And we know that we need to be at 34. So if I'm trying to break this into even parts of 5, like 1, 2, 3, probably 34 is about here. And so we'll put a point there.
And then we got to go 2 down. It's a 5 between 30 and 35.
Right, so if we go down 2 from 34, what would we be at?
Right after
32. And that's right. And then we also need to move to the right one. But look at the bottom here. This is also going by 5s. Let me ask you this. Is there a way that I could rewrite the slope so that the x part of the slope were this 5? So that we could make it work right onto the grid?
you add.
If I change this bottom of the slope here, if I take this and equals negative 2 over 1, how can I make this bottom become a 5 from a 1? It will change the top part the same way. Times what? Times 5. If I do times 5 over 5, what's that going to give me across the top? Negative 10. And at the bottom? 5. Okay?
So we go down 10 and go across 5.
Down 10 and across to which direction? Right. To the right, 5. Excellent. And so if I know that going down 10 and right 5 is the same as going down 2 into the right 1, if I'm at 34 and I go down 10, where am I now? From 34?
No.
24. So again, I'm just under that 25. But it also needs to go to the right. How many?
5. So you go to the right on the left side.
Yeah, right here. Right on that line for 5.
And you do it over and over.
And I could do that again. I can go down 10 again. And to the right 5. Can I do it again? Down 10 and to the right 5. So
And
now we're
that's
at...
because you can't go negative 20.
But what x or what y value do we have here? 4, right? It's right about 4. Now, I can't go down 10. Can I go down 2?
Yeah.
Yeah, I can go down 2 and over 1. And that's going to bring me from 4 to 2. And can I do it again?
Yeah.
So that's going to bring me down 2 again. So that would bring me to actually 0 on the y. And if I move to the right 2, I'm at about 17.
Right there.
Yeah, we're kind of right between 15 and 20, a little closer to 15. All right? And so now we can actually draw our line,
So no arrow.
our boundary line. And that's right, there's going to be no arrows. Why?
Because you can't go negative 20.
Yeah, you can't score negative points. Why do you say it's going to be a solid line?
Because it's greater or equal to.
Yeah, if we look at this inequality symbol, right? We're looking at this inequality symbol. it's showing that it's got that underline. That means or equal to. That's just like the closed circle when we were graphing in one variable on the number line. So what did we say, solid or dashed line? Yeah, we're going to have a solid line here. Not bad. And yeah, we can't go past this part right here because that'll give us negative y values, and we know that you can't score negative foul shots. Same with why you can't go past the y-axis. You can't score negative field goals. You can't go over them. Yeah, so we have a pretty good consensus that we shade above. Why do you guys say shade above? Yeah, it has to be bigger than or equal to. So what we're saying is that this y value has to be greater than or equal to this boundary line that we have just graphed right here. And if we're looking, do the y values get greater than above that boundary line or below that boundary line? Above. And also, if we check our graphic organizer, it says if we solve it for y first, we can look at this inequality symbol and it tells us. If it's greater than, we shade above. Good job on that. So if we're looking, we were supposed to write and graph the inequality in two variables. Have we done that? No?
Yeah.
Yeah?
Yeah.
I would say we have, because we wrote the inequality, right here. We solved it for y to get it into slope-intercept form, and we graphed it right here. Was that all you needed to do? Look back at the problem, write and graph an inequality. So since we did the graph the inequality, the follows the different numbers of field goals and foul shots. Now my question to you is, what are some possible combinations that you could have achieved this, and how do I figure that out? What do you got for me?
Any point that's above 35, 34, or
well, using the graph, how do I tell which ones are solutions and which ones aren't? That's right. Anything that is in the shaded region is a solution. So somebody give me a combination in an ordered pair form for these possible combinations. We got 2025. So again, I'm going to write that in ordered pair form. And remember that that is x and then y. Just like alphabetical order, x, then y. Our possible combinations are going to be, and you said it was 2025. So if I find that on my graph here, if I go over to 20 and then up to 25, it's in the shaded region. That means it is, in fact, a solution. And so if I put that down here, 20 for x, 25 for y. 2025.
15 and 20.
We could use 15 and 20.
35 or 2.
Yep, 35. Is that what you said? 35, 35. Yep, 35. 35 definitely works. Sure, we can keep coming up with them. I mean, we can come up with a whole bunch. As long as it's in that shaded region, it's going to work. Now, 25, 30. No, 17-0 is kind of close. Now, is that going to work? You say yeah. Why? Well, consider what these ordered pairs mean in terms of the problem. If I have 17 for my x, that's field goal scored. How many points is that altogether? 34. Did I need to score 34 points? Did I do that? So what did I do in that situation? We tied. How about in these other situations? We won. Good job, guys.
Wait, is 034 100?
0.35 does count, because if I score 35 points in foul shots, did I score 34 points or more? Yes. Good job, guys.